Welcome to Recursion. We are talking about the problem-solving technique named recursion today. Recursion is the decomposition of a problem into the smaller subproblems that we know how to solve. In our example, we have a function to calculate the factorial of n, but we know mathematically the factorial of n is equal n times the factorial of n minus 1. This gives us an ability to write a function that calls itself in order to convert this mathematical formula into a code. We are seeing that in this code we have an if and else statement. The if statement represents the simplest case that we are able to solve this problem, and we know that the factorial of 1 is 1. And on the else statement we are building the answer for n with calling the same function with n minus 1. In other words, we are reducing the problem size. This requires us to have a recursive calls in order to solve a problem for n. We want to make sure that we always have the base case at the first, because we don't want to end up with calling infinite loop a function to itself. So in this slide you can see the call events of calculating the factorial of 5, which is equal to 5 times factorial of 4. In order to calculate the factorial of 4, we need to call this function by itself for calculating 4 times factorial of 3, and we can continue to this until we reach out to factorial of 1, which is the simplest case. And in this case we know the answer for the factorial of 1, and it is 1, and this is the part that we can trace back and go back to factorial of 5 with 5 steps and calculating the factorial of 2, factorial of 3, 4, and factorial of 5, which is 120. The alternative version of the factorial is that we can store the remaining part into a variable and then multiply it. So in this way it is more easier for people to understand. Let's take a look at the factorial code at visualizer. So when I hit the forward button, you can see each time we are calculating the factorial, we have a frame has been created, and now we are calling the factorial of 4. Again we are going to the function of the factorial to calculate 3 and 2, and we are creating a list of calls, and when we hit the number 1, we can calculate the factorial of 2, 3, 4, and the last one. This shows that every single time we are trying to calculate the factorial of a new number, we need to make a new call, and this requires us to store more data, and this shows one of the weaknesses of this method, which is getting more space.